So welcome to this event. It will be 4 hours on Yang and netconf, so I hope you're ready. So the agenda is like this. We're going to have 2 hours on netconf and Yang. So this comes from the Yang model coordination group. So we want to have modules of trainings. The first time it's about Yang and netconf. There are things that we are not covering here. These are for future use, future developments. This is RESTconf, and what if you are a developer using libraries, etc. So it might be for next time. The second part, after maybe a small break, is how to use pyang to compile your Yang models. We still have some models that are posted in IETF draft that don't compile correctly. In January, we're going to have part of IDNets. We're going to have the pyang compilation that will give you all the error messages so that you post a draft without any compilation errors. In the meantime, we have a website that I guess you're going to speak about, the Yang validator.com. And the last part of the agenda is what we've been having, the Yang advice editing session. We're going to have the Yang doctors here. If you are working on a Yang data model and you want to get some advice, not like compilation errors, I mean, this is not the point, but you can ask questions about that as well, like design questions, then come with your Yang model. We're going to have a list of all the Yang models. One doctor will be assigned to you, and you will receive like free consulting. Otherwise, you can go and pay later on. And I think that donation like beers are welcome. What else? This will be recorded with Meetecho. This should be on YouTube later on. Not the last part, doesn't make sense. There is nothing to record there, but netconf, Yang, and the pyang part. So please make sure you use the mic. Otherwise, I mean, we're going to lose the questions and on YouTube. And I think that's it. Enjoy.
Okay. So I'm not going to use the full 4 hours. I'm going to use 2 hours, or try to use 2 hours. So what I'm going to try to do here, guys and girls, is I have 2 modules that I will go through. This is newly created training material, and the intent, again, from the Yang coordination team is to take it, make it useful, and make it open so anyone can use it, take it and run with it. So this is a trial shot. You guys are the test audience, which means that for me to take anything out of this is I need feedback, I need questions, I need raised hands, and whatever you can, give me. And of course, it's a scary crowd. Some of the people that actually wrote the spec is here, which makes me a little shaky. And I'm leaning on them to help me to, fix any inconsistencies. So 2 sections, they're roughly the same size. We're going to start with Yang, and this is the way we structure this, the way we want to do this training material here is along these lines. So we're going to use an example, a somewhat real-world example, and walk you through the Yang models that we have. Some of them, some parts of them are actually standards track or standards. Some of them are drafts. So we're going to use this example to walk you through the features of Yang. Okay, so it's not I'm not going to go through the RFC or anything like that. Try to make it a little bit more audience friendly. And hopefully when this is all done, you should be able to definitely understand Yang, understand the moving parts of it. Again, there will be a lot more to learn after this tutorial by reading the specifications, by diving into the actual sea of Yang models that we now have in the IETF and in other places. But you should understand, be able to identify and describe the common elements, and more importantly, perhaps, you should be able to take a look at a Yang model and understand what valid configuration or valid instance data, according to that Yang model, actually is. Because, as you guys may or may not know, I'm going to say it now, Yang is a data modeling language. This is one of the things that we keep coming back to with many audiences. It's a way of describing, in a schema style, what is the value space for valid instance data. So it describes what you can do, not the actual instance data itself. We're going to use a couple of Yang models here. As you may know, we are now producing a steady stream of RFCs that includes or has Yang models in them. Some of them have a single Yang model, some of them have several. So we're going to use some of the ones that we believe are going to be core for anything network related going forward. So if there's somewhere you want to start on Yang, and most of the people here are network centric, the ones that I would start with is the IP interface management and IP management. That's a pretty obvious starting point for any kind of understanding on how to apply this to networking. How do we define what an interface actually is? That was a fun journey to actually agree on a way of structuring interfaces. And how do you actually configure IPv4 and IPv6 on this structure? And then we're going to use some types and interface types. And we wanted to make it a little realistic. So we're going to put it in an MPLS context. There's a couple of directions. We randomly picked the MPLS static LSP model from the open config group. So the combination of these should give us enough that we can actually configure a reasonably realistic environment. And the environment kind of looks like this. We have three main tasks that we use to drive you guys through these features. We are going to enable some interfaces. So take a look at what are the data structures that you need to understand in order to enable interfaces on the routers. We're going to assign IPv6 addresses to the newly enabled interfaces. And then we are going to configure static MPLS LSPs. Okay? That's the entirety of the journey. Hopefully along this journey, you guys will have a good understanding then of the basic features of the Yang language. So we're going to start off by the first task, enabling the interfaces. And of course, Yang is a data modeling language, and don't worry, we'll get into the curly braces real soon. Some of the things that we're going to look for here is, of course, structure, right? There's a structure to the data model. There's a big difference in Yang between configuration and operational data. We're going to look at both built-in, meaning that there are data types that is part of the Yang language. There are now also a collection of IETF data types, and we're going to look at how we customize, where you can actually extend the data types to create your own. We're going to look at conditional features, which is a very powerful construct. We're going to look at abstract identities, which will make more sense later. And then we're going to look at what maybe database people would mention to be foreign keys, or in this case, references to other nodes. So those are the main features that we're going to look at in this part. And it's useful to start from the top and look at a visual representation of the data model that we're looking at. So in the IETF, as I mentioned, we took on the daunting task of seeing if we can agree on one single model for interfaces across all vendors and across all stakeholders. And the visual modeling of this is this. There's two data trees, if you like. There's one data tree to the left, or actually in Yang lingo, we would say containers. So there's two containers in this data model. One is called interfaces. It's actually a list, and it's got a couple of parameters, a couple of data points to each member of the list. It's keyed off a name. It's got a type. It's got a Boolean that describes whether it's enabled or no. And it's got a way of mentioning whether we're going to enable traps for this interface. Okay, so that's the read-write part. That's what you can configure. Okay, and then we have to the right side, we have a read-only part called interfaces state. Okay, they look quite the same in general, except for a couple of things. For example, operational state like date and time. When did this interface change last? If you guys, for those of you who have a background with MIBs, you will recognize all these things. We didn't reinvent much, but we actually took most of the things that we had learned from the IF MIBs and translated that into useful Yang. And in order to support stacked interfaces, we needed also to be able to reference from an interface to another. And the reason why we split configuration and state was that in many systems, you can actually have available interfaces that are not configured. A newly inserted line card might not necessarily have configuration, but it's around. So it probably has operational state. You may also have configured interfaces that are not physically around. Many vendors allow for pre-configurations. You're able to set stuff up while waiting for a line card to be slotted in. So we needed these to be separate entities, so one could live without the other. There we go. First question.
First
Yes.
raised hand. Dan Romascano is my name. So can you comment just shortly for an operator, how familiar will be the interface in the interface model in Yang relative to the interface in a MIB2 SNMP environment?
I'm about almost to play that back to you. Do you want to comment on that, Dan?
No, it's actually a question about the realization, because I can comment a lot about history, but what resulted is actually interesting, probably for the audience from an operator point of view, how close we are with the interface model that we are familiar with.
Okay, I'm looking unsure because I am. So we ended up reasonably close. I guess it's a flat list. Maybe that's important. So there's no, for example, there is no containment. So there's no tree structure of interfaces. So in terms of stacked interfaces or layered interfaces, that's solved by the interface state ref rather than actually using a tree structure for it. So I'd say it's reasonably similar. If you look at the details, again, we won't go through everything. There's also a nice mapping to the IFMIB name. So there's a way of actually figuring out, based on the data you get from the netconf or restconf interface or the Yang defined interfaces, which MIB interface this actually refers to. Kind of what you were asking. Thank you, sir. And here's another thing that's important. Throughout this presentation, this is kind of what I visually struggle with a little bit, so I'm going to try this on you guys. There's a big difference between when I talk about model structure and when I talk about instance data structure. So the model would typically be in Yang, and the instance data would be your actual configuration or operational data, your counters, right? So the interfaces list, of course, to the left here, the model says that there's a list of interfaces. They're indexed off of the name of the interface. I told you about the other leaves. But of course, in the instance data, you have a number of instances according to the model. Clear. Okay, there's a little sea of nods, so that seems to be okay. And well, the example here, of course, shows that they might look the same. They are the same type. They're enabled. Well, this guy actually has the link down trap enabled and enabled false. And their names, their keys are ETH0, ETH1, or ETH3. So there are differences, of course, between the list entries. Okay, here we go. Here's the first glimpse of Yang. All Yang files have a header. And again, if you guys have any background in MIBs, you will be surprised about nothing here, right? These are mostly, and we'll go through the details, informational stuff. So you have your organizational affiliation, you have your contact information. But things to pay attention to on the top here is actually the module name. This is really a key feature or key thing about Yang. All modules have a name. That name, for good module writers, need to be globally unique. So you need to spend some time thinking about the structure of the module name. Now, if you develop Yang modules in the scope of the IETF, you're good, because we actually suggest a structure. And by prepending IETF, we have some freedom of making sure that we don't overrun each other. So the module name is important. And also it ties into, this comes as a surprise for some people, that there's actually a formal mapping from the module name and the revision, we'll get to that, to what the file name for this Yang module should look like. So a file, a formally well-specified Yang file, is supposed to be a concatenation of the module name, IETF interfaces in this case, and the revision, okay? So the formally correct file name for this guy here would be IETF interfaces @ and the revision .yang. Okay, this is new. This helps quite a bit for tool makers. All they need to know when looking in file systems is the module name or the module name combined with the revision, and they can look in their paths or what have they, and understand this is the connection between the module and where the physical manifestation of it is. Okay, so that's important. And the module name will come back later. We have a namespace. So netconf uses namespaces because there's XML encoding on the wire. So we need to make sure that we can actually separate data sets that might be intertwined or close to each other based on which model it comes from. So you declare your namespace. That's supposed to be a URI. So you can either take a URL that you own yourself, like a domain name or HTTP, or in this case, again, if you're with the IETF and produce these things in the scope of the IETF, we have a IANA registered namespace, a URN IETF. Yeah, you can see the path going there. And you prepend the module name. These are the things that our validating tools keep running up against. So it actually pays well off, especially if you develop things inside the IETF, to pay some attention to these things, to make sure that they're actually correct, because that helps you later down the line. Also, kind of an outcome of the fact that we have XML bindings is a prefix. So you need a prefix, and it will also come back when we talk about imports and includes. So you have to come up with a prefix, make it short, don't have to make it interesting, but make it short and make it, you know, reasonably easy to remember. And very importantly, we have, or the Yang language, and there's a lot of nice things written about this in the RFC. The revision statement is on a date format and describes, of course, when this Yang file was published, whatever that means. For us in the IETF, it means something very specific. For private writers or for vendors, it might mean something else, but it needs to be in a date format. And again, it uniquely identifies the version of the Yang. So we don't have any other types of versioning. It's actually the date format here. And of course, we realize or understand or plan for the fact that there will be later manifestations of IETF interfaces that will have new revision statements, okay? And there's something called import by revision, because, of course, if you import, you want to be able to import the specific version that you're looking for. Okay. So let's start from the top. I showed you, if you remember, that there were two top containers in the IETF interfaces Yang module. This is what the container feature or the container keyword looks like. It is doing one thing and one thing only. It does containment. It's a way of grouping things together. It ends up, of course, in your tree path, but it has no semantic value except for that. Defines an interior data node or data nodes in the schema tree. And usually there's a list of child nodes. And of course, you have one or many of those on the top of your module. It's the staple of Yang, if you like. The next most common feature, or the next most common construct, is the list, right? In this case, we have two lists. We have a list of interfaces, and I mentioned we have a list of interfaces state, okay? So two lists on the top. Single argument, again, it's the name of the list. Represents a collection of entries. Each entry consists of one or more nodes. Nothing strange. There's a couple of things in Yang that might trip people up a little bit. Is that there are two types of lists, or there, well, there's two types of lists for this purpose, right? It's that, and I mentioned this early on, that we make a strict difference between data sets that are configurable and data sets that are operational data. So by using the config false construct, or the config keyword with a false argument, means that all data in the interface's state is immutable. It's read-only, okay? So as I said, that represents the state of the interfaces. Nothing you can do about that. All lists that are configurable in Yang, like the interfaces list, must have a key. This is what I know some people are tripped up on, right? So in this case, we have a key called name, right? So the index into the list, the way to identify list entries is by the index or by the key name.
This is Kent. Just a minor clarification. The
Go.
key is only required for config true.
Good.
No, yeah.
Okay, true. Wait, good one. What he just said was that we have two types of lists in this example. We have a list of things that you can actually configure, interfaces. We have a list of things that you can't configure. And even if, and maybe this is where I should update the example, there's a key statement here, you can actually remove this. It's fine to have config false lists with no keys. Okay. A little bit of nodding, that's good. List entries are defined by leafs. So if you have a list interface with a key name, then you're of course expected to have a leaf called name. Defined by an identifier and has a type. In this case, we have this, probably the most common and the most simple one. It's of type string. And in this case, then, of course, the leaf name serves as the list key of type string. Good to have some editing advice on the screen. And if you look at the model, of course, again, we describe the fact that interface is a list, has names, has members identified by a string called name. And of course, an example instance of this would be that you would have interface list members called ETH0, ETH1, ETH2. Okay? As I mentioned, string is a very, very basic type. Of course, the Yang there we go. Yang itself, the language, comes with a set of built-in data types. Not much new here. We didn't invent much, of course. We got quite a bit of input or feedback actually from, of course, from people with a MIB background and, of course, normal programming language efforts. So you won't be too surprised. We have a binary, we have bits, Boolean, decimal, 64. We have the common ints, unsigned 2. We have enumerations. I will pick out some of these and actually get to them later in the presentation. Union, well, nothing particularly strange here. Depending on what type you have, there are also qualifiers, if you like. So things like pattern range and length that you can use to restrict the value space for particular types. So in this case, it's an example of a string that has the length of 4, the lexical length of 4, so 4 actual, if you like, letters in the string with a particular pattern, which is a regular expression. This is actually, of course, then the core of most of the derived types like IP address, like IPv6 address, and so forth. Basically strings, but with a pattern to them. So in this case, for this interface, we have a leaf called enabled. It's of type Boolean. Oh, there we go.
Yeah, on the previous slide,
yes.
You can go back. So you specify the pattern for each character. How do you do that? Yeah.
So in this case, what this says is that the value space or the lexical space, or the length of the string is between 0 to 4, and that the pattern that the actual instance data needs to match is this pattern. So what this says is that, you guys are probably familiar with the regex. So the members need to be in 0 to 9, A to F, or A to F. Right? So it's a very crude maximum 4 length hex representation.
Okay, thanks.
Okay. Okay, so for this interface, we have a leaf called enabled, which of course describes the configured or desired state of this interface. Is it up or down? Very simple. And Boolean also allows you to put a default value. So default is if you don't do anything and this leaf is actually instantiated. So if you create this leaf, but you don't provide a value for enabled, the system will work off of the assumption that it's going to run as true. So if you create an interface, it will come up. That's the effect of this. And of course, an example, again, this is the model. We've added the Boolean leaf. An instance could be then that, well, all 3 of these interfaces are up. Okay? Next step, I mentioned that we have a leaf called link up down trap enable. that controls whether we send SNMP traps when something happens to this interface. This is of type enumeration. You will recognize this again from most programming languages in the world. You define it by saying type enumeration, and then you enumerate the enums. Here we go, another question.
I just have one question. I'm pretty late, but the list interface key equal name.
Yes.
Does it mean that we have a name is for the list or for the further interfaces?
It's the key for the interface members. So
Okay.
yeah, so all interfaces must have a name field, must be unique, and that's how you uniquely identify one of the members.
Okay, thank you.
You're welcome. Okay. Oh, sure. Now we're getting warmed up.
You have here a link up-down trap.
Yes.
In the previous slide, you have enabled, and enabled is actually configured enabled. So I can configure an interface as enabled. At least
Right.
I think so. I'm just going.
Yeah.
And it might not come up because the other side is not up, the laser is not on,
Right.
all kinds of reasons. This trap is probably for the operational up-down versus the configured up-down.
Man, good point. Good point. Did anybody catch that? Okay, so there's difference between operational up-down and administratively up-down. Okay, you can wish for your interface to be up forever, but if there's no cable in, it won't come up. So good point. Thank you. And it ties right into the SNMP definition, so we'll piggyback on that. Okay, so two members, enabled and disabled, not surprisingly. There's an optional value to it, so you can say that actually, as part of the netconf protocol, we want to assign a specific value to the enum. Yep.
Another question?
Good. Yes.
Switch order on graphic? I wasn't paying attention when you explained
Yes.
what that was.
So I've had that twice now, actually. Yes. A little, editorial things for myself. I should have probably gone through that before. Yeah. I want it to be flipped. I want the graphic to go on the other way around. See what I mean? It's very confusing, also to me. I should just, all directories go to the right, don't they? Yeah. Okay, defining new types. So we have a keyword called type def. Okay. In this case, we are doing the right thing. We're defining what percent is. We pick unsigned integer 8, and we say it's a range between 0 and 100. And we put a very descriptive description in saying percentage. So by doing this, in scope of the same Yang model or module namespace, we can now use this as a type. So if we later or in the same module have a leaf code completed, we can just freely use type percent. Very clever. There's a couple of things that are not part of the Yang language itself, but things that we do well in the IETF, which is types related to networking. So we have in RFC 6991 a lot of common Yang data types, both around INET, but also extensions of Yang that are more generally applicable. And I'm going to say this now and many more times, do not invent your own types before you have at least looked through 6991 and a couple of other places over time. I've seen too many interpretations of MAC address, domain name, IPv6 address. We've done that. Some of them was horrible, but we've done them in a way that we think are stable and useful. So look at 6991 before inventing your own type def. You may have noticed 2 slides ago that there was a little keyword that I hadn't mentioned before called if feature. This is cool. This we haven't had before. The feature statement actually allow you to make parts of your model conditional. So in this case, the leaf that I talked about with a long strange name, link up, down, trap, enable, only applies if your box supports SNMP, right? But we don't want different models, formal models, for boxes that support SNMP and for boxes that don't support SNMP. So we have the feature statement. In this case, feature ifmib means that here's an optional switch. For systems that support ifmib, this leaf applies. So we have paired with the feature, we have the if feature. So in this case, for this leaf, the if feature, ifmib, means that if this box supports ifmibs, this leaf will be visible. For boxes that don't support ifmib, you won't even see it, but your data will be valid according to the model without that leaf. Okay. So it's a powerful way of reducing friction among editors of a particular. We can push many of our discussions into the feature space, if you like, and make it optional, not a deviation or anything like that, nothing negative, just make it a feature.
So is feature like hierarchical? Let's say I'm writing a Yang model for a new protocol. So where do I start with? For, let's say I have two separate functions in that. Within the function, I may have a number of capabilities.
Yes.
So how do I organize that? How do I, for the top level functions, should I say, these are the top level features now within the subset of the individual features within that function, can I link them? In other words, is there like hierarchy there?
I'm going to glance over to my fellow Yang people, and I'll start on a response, and no, Kent, take it away.
This is Kent. So I think if I understood the question, you could have a top level container with one if feature statement and then a nested container with a different if feature statement.
Yeah.
So there'd be an anding between them. Okay.
It can be done.
Yes.
Do you want to say the difference between if feature and augment?
Within an augment statement, it could also have an if feature
So
statement.
this,
yes.
instead of leaf, this could be an augment, right? So if you place the if feature under the augment, it will be optional on an if,
And
on a feature.
But I didn't see the relation as how you're tying a particular feature to another feature. How did I group it? How did I say that this particular feature is part of some other, is tied to some other feature?
Now, this is a good question. Now, Kent, let me ask you this. Can you put an if feature under the feature statement? because that-
No, I don't
right.
think so.
Then I don't know how to do.
But you can now do Boolean features, so you could have an anding of them. That would
See, it's
essentially
good to
group
have the
them
working
together.
group co-chair in the room. That's great. Is that in Yang 1.1?
It is.
Okay, so it's in the soon to be published Yang 1.1. What you're asking for is possible. Okay. Good flow of questions. Thank you. Keep coming. Keep going. Okay. Abstract types, identity refs. There are, I've talked about like two ways of enumerating things. Of course, there's the list and there's the enum statement. There are many occasions where we end up having to enumerate something that we know will be heavily extended over time. And since we want Yang modules to be fairly stable, i.e. don't change too often in terms of a client developer, let's say, we can't really use, we can't really easily extend enums. That will change the value space too much for the client developer. So we have something called identities. Identities, in my mind, or the way I usually use them, is as an extensible enum. So a good example of this is what I'm showing here. As you guys may know, IANA keeps track of all interface types, or at least all registered interface types. It's a list of types that changes at all times. It's a ever expanding amount of strange types of interfaces that we invent and use in the industry. So of course, we would never submit a Yang file that actually tries to capture everything that will ever be defined. We would rather punt this and say, look, an interface type is an identity, and we use what's called an identity ref to reference identities. So by including, and we'll get to the actual machinations of inclusion, or how to include things and import things, you make a list of interface types available, and therefore the type leaf here can then reference those identities, okay? And this allows us to actually expand these identities without upsetting the client developer. So it's not actually changing the structure, but it's changing the set of identities over time. So of course, again, interface type in our interface example here is a perfect example of that. Did that make sense? Kind of. Okay, I'll practice on that slide. So let's take the leap. Here's what we've done this far. We have our little network here. We have a management station up top. We have 2 routers. They have ETH0 interfaces, both of them. And we want to assign them eventually IPv6 addresses. But our first task was to walk through the interface model enough that we could actually bring up the interface. So the configuration and the examples that we have here is actually the XML instance data that you would typically see in netconf. This could look different if you have other protocols like RESTconf with JSON. But in XML, this is then what you would send. You would send interface, and you would provide a name because it's a key, so it's mandatory. And you would set the enabled leaf to true. You would send that off to the routers. And if they have interpreted the YANG correctly, which they have in this case, they would bring up the interfaces. Any kind of catch-up questions this far before we head into the operational state of things? Okay, good. So we're going to focus on the, if you remember, the right side of things for a little bit. This is the read-only side, the interfaces state. So in the read-only space, there's a couple of things that are interesting. As I mentioned, each entry in the interfaces state list represents the state of an interface, which sounds easier than it is. It represents the state of an interface that is actually available to the system, right? Whether it has configuration or no, it's something that the system knows about. And the first one we have to take into consideration here, because we make use of it, is imports. So the example here is about imports, but I'll talk briefly about includes too. YANG structures all its data into modules and submodules. Oh, there we go.
Just one question about the states.
Yes.
Are they necessarily implemented, or, for example, if one is having the color of the router, blue, red, maybe other vendors don't want to implement that. So can we have optional states, or?
So in this case, actually, the interface's state tree is optional. So you don't have to implement the interface's state tree. But I think most people would be very surprised if they found a device that doesn't want to talk about the interface state. But I think, yes, it's actually optional. You may have, your system might be in a state where you don't have any interfaces, so the list will be empty. Okay. Okay, so YANG, a core concept is modules, right? So in this case, where we are now, we actually need a couple of types from the YANG types module. So we go ahead and use this keyword. We use the import keyword, and then we use the module identifier. And this, again, is the unique way of identifying what you're looking for. And it's the module name, right? You can also import by a revision. And in that case, you would actually say, using the revision statement, what revision you're looking for. But your tools would then go look for, in some sort of catalog, maybe the file system, or maybe some other means of a module with that name. And import makes the data definition, so basically the data tree that you have in that module, available to your local module. So typically, if you need some types or some groupings, and we'll get to that, this is the exact statement that you would use, right? And you also provide a prefix keyword, because when you then use the types from this imported module, you need to prefix them, and I'll show you an example, because you want to make sure that you may have types in your local module that has the same name as the newly important one. So we use the namespace prefix to discriminate between the two. There's also the include statement, not part of the example, but nonetheless important. Used to make content from a submodule, and a submodule is actually a YANG module that you declare not to be a module, but a submodule. So it's a specific type of module called submodule that belongs to a specific module. It's more, in my mind, a way of breaking up very large YANG modules into perhaps smaller. It's more like the actual include statement in C, for example. It's a way of just breaking out a lot of information or a lot of text into other files. because you can't really export, or that's not a way of importing things. It's just by sucking that data in. So it's not something you would use to, for example, get a hold of certain types. It's just a way of breaking your module into many smaller parts. Okay, good. Here's the example import that we use. Okay. We import IETF Yang types. Here's the snippet from IETF Yang types that we're going to use, because we need date and time for the last change leaf that was in the interfaces state list, as you all remember. We have a type def. We looked at that before in the IETF Yang types module with a nice regex for ISO date. I think it's date. And yeah, date and time style data. So by importing IETF Yang types and then calling out the type with the Yang namespace prefix, we can now use the type locally. Okay. So more specifically, it looks like this. Our instance data, or the model is here, right? The instance data is ETH0 has a particular date time. ETH1 has one more clerical error here. This is what the a conformant value then to the regex here looks like. So that's a derived type that we have imported. Okay, so it's not a base type. Yep, here we go. I did, I know. That's why this is not marked up. Keep reminding me. Okay, so I mentioned also that we have foreign keys. They're called leafrefs. So it's a way of referencing another leaf, okay? And what it actually means is referencing another leaf instance, right? So we use leafref to do that. And in our model here, I mentioned that we want to support stacked interfaces, interfaces that sit on other interfaces. And in this case, we wanted, that's another error, VLANs, no, it's actually correct. On the right side, down there in the instance data, you see that an interface called VLAN 0 actually have a higher layer interface entry called ETH0. And if we look in the Yang model, you can see that the type def for the interface state ref is of type leafref, okay? And the cool part here, where a lot of interesting things can happen, is in the path statement. Yang is inherently tree-based, right? You can always uniquely identify nodes in a Yang model or in an instance tree by the path, okay? So in this case, we say that the value of the interface state ref must be a member of the IF interface list's unique name. What this does, which is pretty cool, is that it formally helps you to avoid dangling pointers. The only actual valid value here is existing interfaces. This does a lot of cool things, actually. So in this case, we're actually talking about read-only. But if you think about what this means to also the read-write, is that you can never, for example, reference an access control list that doesn't exist, which is otherwise one of the main reasons why our network connectivity now and then goes away, right? We can formally restrict the value space of a leaf to another leaf, make sure that there are no dangling pointers. And the reverse effect of that, maybe I should have a visual for this, is that if you have an instance that points to something and you try to remove that something, a nicely well-behaved Yang system will say, you can't, because you have incoming pointers. Someone is referencing you, and if you go away, the data set will be invalid. So getting leafrefs right can provide a lot of nice tightness to your models and help your users to avoid a lot of mistakes that were historically based on the fact that we allowed for dangling pointers or references that didn't reference anything in particular. Okay. So, okay, so let's hit task 2. Now we know enough that we can actually assign an IPv6 address to the interface. The interfaces module that we looked at this far didn't actually go so far as to layer 3. So it didn't actually define the data set needed for IPv4 or IPv6 addresses. For this, we need IETF IP.yang. And in this IETF IP.yang, we will have a new set of model. We will look at the IPv6 side of things. All IPv6 per interface IPv6 configuration will consist of a Boolean leaf to say, is IPv6 enabled on this interface? And it will have a list of IPv6 addresses and prefix length combinations. Okay? You will recognize this from typing things into the CLI. And what we're going to use is a very powerful feature called augment, or powerful keyword called augment. Augment is a way for a module to, if you like, mount itself into another module. So bear with me. What we do here is that we import from IETF IP.yang, we import IETF interfaces with a prefix if. Okay, so now we have the data nodes from interfaces available. And then we say, using the magical incantation, augment and a path. Under interfaces interface, so we're in the read-write section of the interfaces module, augment this. And we provide a container called IPv6. Okay, so by doing this, we have suddenly kind of mounted ourselves into the IETF interfaces data set and added a container IPv6. Okay, so this provides the groundwork for the actual configurables to do with IPv6. And this allows the IETF and other SDOs to write the let's say the backbones of what they do first, and then have teams, in our case working groups, augment themselves into this. That's the machinations. Then starts the actual work. So there's a lot of work going on in many working groups about how do we augment ourselves efficiently and organize ourselves efficiently around each other's modules. Okay, but it's a very, very powerful concept. And the IPv6 model, and this is the demo version. As I mentioned, we have a leaf called enabled. It's a type Boolean. You've seen that before, default true. We have a list of addresses. The key to the address is the actual IP address. And we reuse the IETF definition of an IPv6 address with no zone to it, because we use the prefix length, which is of type unsigned integer 8, with a particular range. Here's another actual keyword that I haven't mentioned before. Mandatory true. Of course, all keys are mandatory. You can't create a list entry without having a key. But this also says that we won't allow you to create an entry in the address list without a prefix length. So it's not a key, but it's mandatory. So trying to create it without a prefix length will be an error. So here's the instance data in XML. So we now have two routers. So we have interfaces interface, and we identify the name, ETH0. It's under IPv6 when there's actually new. So we need this interface to be enabled. We've added a made-up address, and we have a prefix length. And you would not be surprised to see that it looks exactly the same towards router 2. Oh.
When you say that the key is IPv6 address,
yes,
and if someone put a leading 0 in it, in IPv6 address, this doesn't have the semantic knowledge that that actually is the same address. It'll treat that as a different key. Yes, no? Yes.
Treat that as a different key.
Okay.
Ah, perfect. Thank you. I have the full support team here. It's beautiful.
Actually, we have a concept which is called, what's the name again? I forgot.
Make it up.
No, every data type has canonical format. And
yeah,
that's the idea that these comparisons, like for keys and also for XPath expression evaluation, you need to use the canonical form for comparing it. So in the same way at RFC 6991, or what the number, we have a canonical format defined for IPv6 addresses, which is what you would expect. It means no leading zeros and so on. So this is what you need to use for comparing keys and so on. So in this case, these will be the same key, so an error, basically.
So does that mean that Kiridi should provide the input in canonical format? Or does it mean that the system should canonicalize?
No, the system,
Before
when,
comparison.
when checking
When checking.
uniqueness of
Okay.
keys, it
Okay.
will use this canonical format, so it will be flat and error. You are not allowed to
Got it.
have different different IP addresses differing just in leading
Good.
zeros.
Good. Excellent. Okay, cool. Interesting. There you go. Yep. So, okay. Hopefully nothing particularly exciting here. Now, of course, the subtle message in this slide is that it would be cool if router 1 was from vendor A and router 2 was from vendor B, right? And you send the same payload. See, now we're thinking. That is what we're trying to do here, of course, by providing, because again, all the examples I have here is from IETF submitted Yang modules that we dearly hope that vendors and service providers will pick up on, because they don't discriminate. It's the same data structure, but of course, vendors can then go ahead and use powerful features like feature and augment and other things to extend things, because of course, vendors need to have something attached to the address that makes their thing go faster. Go ahead.
So I don't think vendors need to agree on the interface name, though, right?
That's true.
Okay.
It's an opaque string. As long as it's unique,
Yeah,
they're fine.
my question would be, what would be the expected behavior if I configure an IPv6 address with a different prefix length? If there is a pre-existing IPv6 address, but with a different, like with a /128, and I want to /126, is the expected thing to tell me that the key already exists, or is it overwritten?
Back to, I'll start off. The lexical value here will then be canonicalized and compared with the incoming or colliding or potentially colliding entry, right? And if they match, it's a no.
Okay.
So it's a good question, actually, because there's another concept in Yang called unique. There are ways to describe, to say that, look, the IP address is key, but the combination of IP and prefix length needs to be unique. We don't have that here. So it means that this is the only thing we're looking at. So if you try to have the same IP address, but with a shorter prefix length, and they're canonically the same, you would be denied. That would be a no-go. So here's task 3. Now that we have enabled interfaces, we have IPv6 on them, now we're going to configure LSPs. So now we're, you go.
I don't know if I should ask this question.
Therefore, you should.
I like the way you
just
twist and untwist your wire.
Yeah.
If I were to say, and I don't know V6, so I'll say it in V4, 10.1.1.1/28, that's broken because the .1 is not a valid /28.
Right.
Is there a way to say you can't do that, or is that up to the backend system to say, I'm trying to configure this, it didn't make sense? Can I, in Yang, say, in my data model, say that's a meaningless thing?
No.
So it
right.
would,
I think this particular case is for backend.
It's for
the
back.
back. Okay.
Yeah.
Okay.
Yeah. There's a what you're poking at, and which you're right in, is that there's a limit to the semantic checks that the language can express. Some things will just have to be done on the back end. Okay, so we want to configure LSPs, and we just completed the team by the actual editor of the RFC here, so that's perfect. Now everybody's here, no pressure. Just a brief walkthrough. This is an interesting RFC, or an interesting draft, an interesting Yang module. It is challengingly large, and it's very ambitious. We're going to look at a very small subtree. So we're going to start at the top, look at MPLS. We care for LSPs. We're going to care for static LSPs only. And we're going to look at the label switched path part of this. But you'll recognize now that we have a container on the top, we have a container in the container, and actually we have a container in the container in the container here called static LSPs. And this uses then the keyword that I mentioned before. It uses the uses statement, and we'll get to that on the next slide. But now you have a feel for what we're going to do. So inside of MPLS LSPs, static LSPs, we have label switched paths that have a name, ingress and egress. They all have next hop, incoming label, or push label. Okay, that's the content of the model. That leads us to Groupings. So groupings are ways of assembling data nodes into named sets that you can reuse. So we talked a little bit about reuse before in terms of type defs, but they are reusable types. These are reusable data sets or data node sets, right? So the way you declare groupings, or the keyword you use, is grouping, and it's got a name. In this case, this grouping consists of a list called label switched path. And you have, yes, you've already seen that, is that both the ingress and egress will use the same data structure, so it's appropriate to declare a grouping and then reuse them. In this list, we have a key name, leaf name, container ingress. And just to make it more interesting, this grouping actually uses other groupings. This is where you start keeping context in your head. And this grouping uses a grouping called static LSP common. Well, at a first glance, at least this grouping doesn't have additional groupings or uses statements, right? So this is the bottom. This is the leaves. Next up, incoming label and push label. And by using a container on the left side, then they both use the static LSP common, we declare this thing, right? And the cool thing here, of course, is that if you choose to change something in the grouping, you don't have to repeat yourself because it uses them. But you also have to be very sure, or not very sure, but reasonably sure that the places where you use the grouping will always be kind of the same. So you don't have to break up the groupings later. Okay. So now we have instance data for the label switch paths. And you will recognize the fact that we have a list of label switched paths, LSP0. We have an ingress incoming label and an egress next hop. Same thing on router 2. Any questions? Because that concludes task 3. And we've now gone through the absolute majority of the features in the Yang language. So in summary, each one of you should now be able to do what we set out to do.
So maybe I didn't understand, like how do you distinguish between a vendor specific versus a non-vendor specific, object model?
So I'm actually one step below that. I'm more on the language level, and there will of course be Yang modules both from vendors and from others. And in the language, there's no specific way to say that I'm from a standards organization, or I'm from a vendor, or I'm from an open source project. Well, the namespace will uniquely identify kind of who you are, but it doesn't say much about anything else. Were you thinking about, you probably had another?
Just trying to understand.
Okay.
So I can augment models to add additional functionality. Can I sort of remove chunks as well? Like if my box doesn't support sub-interfaces, can I say
Yes.
that's something that's defined, but I don't do?
Yes, and I need some of the more seasoned people to maybe add color to this. We really wanted that to be very hard and actually associated with a little bit of shame, because we do want the IETF to write the minimal set, the useful set. Anything less than that would be bad. But there's a keyword that I don't even going to mention here, but I'll do it now verbally, and we'll edit that out, called deviation. That's where you secretly, not so secretly, where you declaratively admit that these are the parts of the model that I don't implement. But we wanted that to be something you explicitly call out, so the consumer can see that this is, you can't just sneak it out of the picture. Good question. Any other concluding Yang questions, Kriti? Always one more question, that guy.
So does feature mean here's a approved or not approved, but an okay deviation?
That's a mean way of saying it, yes. The editors of the specification said that you're fine to not have this. It's okay.
Can we just call deviation deviant?
It would be better. Too late, I think, but yes.
Pascal Hubert, you reference a state like enabled or active or something like that,
yes.
Which is a state, but not the way to put the system into this state.
Right.
Meaning that if I have a sequence of operations, which are all things I need to put in my XML,
yeah.
How do I describe that they are dependent on one another and they should be all rolled back?
Got it. Yeah. So now we're getting into the philosophical domain, but it's really important also when you design your Yang. So there's like a meta model to Yang, and the meta model says that your configuration can at any time be represented as a set of instance data. So the Yang language doesn't allow you to describe ordering in general. It describes a schema on which you can operate. Now, if you think about leafrefs, there's actually a little bit of ordering in there. You have to create, for example, the target of a leafref before you can actually reference it. So there's a little bit, but it's still in the declarative domain, not in the procedural domain. So by identification, I work for Cisco, and if you think about our CLI and other CLIs, some corners of them still have ordering to them, and that is actually parts of why Yang can be painful, because not only that, you're supposed to be able to send arbitrarily large and complicated chunks of data into this and say, I want to turn up a VRF and turn down this IPv6 interface and create 3 new static LSPs in one go, in one single operation.
And roll it back fully if one of these
happens.
actions
Yes.
doesn't work, right?
That's a tall order.
Oh.
That's just what the vendors need. Challenges.
But you don't have it, right? It's not possible to express this transactional thing into Yang.
No, it's in the protocol domain. So it's rather how the protocol. So in NetConf, which we'll talk about in 30 seconds, there's a very strict way of doing those things. All right, how am I on time, Benoit? Perfectly on time. That's great. Okay. I'm going to switch presentation here.